Hello, and here is section 2.5 of our unit. It's called Phonetics and Cladistics, and I don't know if you've heard of these words before, but I realized as I'm staring at the screen that this is a very boring slide. So I apologize for that. Simply, I would like to point out that there are three different ways we can classify species: the Orthodox Classification, Phonetics, and Cladistics. Now let's move on off of this really boring screen. So let's look at first the Orthodox classification method. And when we talk about Orthodox classification, basically what we mean is that we're using subjective and intuitive approaches to examine organisms, and we have to judge which characteristics are the most useful in order to classify them. So are we going to use the beak? Are we going to use the foot? Are we going to use other structures of the organism? Obviously, organisms vary quite a lot. So we're going to have to subjectively decide which of those structures and which of those features are the most important. And that's kind of the classical Orthodox way a lot of the classification has been done. An example would be bird orders. The orders that birds have been classified are a result of this type of classification, and they're based mostly on their beak and claw differences. A second way we can classify organisms is phonetic classification. This was an approach that was developed in the 1950s, along with the next approach we're going to look at. And the idea behind this is that as many characteristics as are possible are taken into consideration, and all of those characteristics are given equal importance. So pairs of organisms or groups of organisms would be scored based on the number of shared traits. So it wouldn't be based on how much a particular trait would be in common as how many different traits they would share and have in common. So you may have a group that ends up being classified that may not share, all of the different members may not share a specific trait within that group. The idea behind it is overall similarity, and it is not used much anymore. It's helpful in classifying really large groups of organisms, but it's also pretty difficult to do and sometimes doesn't give the results that are desired. So another way we can classify organisms is with cladistics. This was also developed in the 50s. And cladistics looks at both ancestry and homologous characteristics that are not found in any other organism. So an example would be mammals. They have milk glands, but no other organisms have milk glands. Therefore, according to the cladistics way of thinking, all mammals must be descended from a species that has no other living descendant, and so they will form a clade or a branch on the cladogram. So down here is a cladogram indicating those kinds of relationships. Here we have a wolf, hair being characteristic of the wolf, but not of these others. Amniotic eggs would be characteristic both of the wolf and the turtle, and so they would both have a clade on the cladogram, indicating that they have that single feature. Four-legged locomotion, that is shared by all of the organisms, all the organism groups below it on the cladogram. So cladistics is a way to basically designate relationship by one characteristic at a time. So here is an issue that has been around for over 120 years, and that is, how do we classify the giant panda? There has been disagreement amongst biological taxonomists for such a long time. Should the giant panda be in the bear family? He looks a lot like the bears. Should he not be in the bear family? He's a plant eater, he eats bamboo. He has a very modified wrist bone that is not like the bears. and he has a large, heavy skull. That's different. He does not hibernate, and the giant panda does not growl or roar like other bears, but bleats like a sheep. There are proponents of the raccoon or red panda family, and even who have said, well, red pandas have 22 chromosomes. That's pretty close to the 21 pair of chromosomes that a giant panda has, and very different from the 37 pair that bears have. So where do we place the giant panda? So there is a hypothesis that has come about called the molecular clock hypothesis, and let me explain that just a little bit. The idea is that as new species develop, genes become isolated over time, and so the differences between species will increase due to the natural mutations in the DNA between the isolated groups. So based on that, an estimate can be calculated on the rate of the accumulation of mutations, and from that, the time of divergence from the ancestor can be determined. And based on this information and this change in the overall DNA in a population, the giant panda, it has been decided, belongs to the bear family. However, the giant panda is still significantly different enough from Ursidae, the bear family, that the giant panda gets its own subfamily. So the great difference is recognized, but the classification will be with the bear family, although not everyone agrees still. The red panda has actually received its own family, and is no longer combined with the raccoon family either. So there's DNA evidence to suggest that the bear and raccoon families separated about 35 to 40 million years ago. So there is still not total agreement, but this is the new theory, the new hypothesis based on the molecular clock hypothesis, and we'll see what happens in the future. It's important to remember that changes in classifications and changes in ideas happen because we find new information and new discoveries are made. Certainly the microscope enabled us to look at things very different from the way they were, rather than the initial two kingdoms that were hypothesized. The microscope enabled us to realize, oh, maybe there are three kingdoms, and we included another kingdom in that simply because we were seeing organisms we had never seen before. So with the discovery of more information, hopefully we'll be able to do a better and better job of classifying organisms. Here is your advanced proficiency page. Look at some of these ideas, think of some on your own, and I'm excited to see what you come up with in class. Bye.